Record on this computer. Okay, so Cheater's Hangman. The thing I found for a lot of students that with the difficulty on this one is just creating the proper methods. So there's a couple of methods you want to be able to create. The first is a method to read the. So I suggest having these 3 helper methods. You could do it all in main, but that's not helpful. So let's go ahead and take a look. So first helper method would be would be a public hash map that will return a list of return a map of integers to a list of strings. Now that seems a bit weird, but let's go ahead and see what the class is. Public hash map. Oh, and these should be static, definitely. It's public static hash map. Read file, which will just take in your, and you can have it take in a file name or whatnot, right? Right, and this will be basically, and what this will do is that this will read your file, or you could instead, or depending on how you want to do it, you can basically take in, or you could take in a list of words after having read the file and pass it to here. But basically the idea is to split up the list into, to split up all the words and to organize them into an initial configuration so you never need to read the file again until you run the program again. So return null for right now. So what we're going to do here is that we have a hash map of integer to a list of strings. So here, the key is the number of letters. And the value is all the words that are key letters long. And so this helps you basically when you read the file, this will help you create your initial word list. Okay. Does that make sense? Once you have a word, basically these are, so basically if the user chooses 8 letters, you can go, okay, whatever this hash map is, grab the, maybe we'll call it, let's go ahead and call it hash map integer, again, list of strings. And this is what I call the categorization use case for a hash map. Again, if you haven't had the chance to watch the videos, hash maps we use for 3 big things, about 90% of the cases. And most of those 90% of the cases, the first 2. First is key value storage, basically given a key, like a username, look up all the stuff associated with that user. Given an email, look up the stuff associated with that email. So basically kind of just like, here's a person's unique ID, give me everything that's relevant for that person. So it's very common in kind of database operations. The second is counting. So given a list of words, given a list of words, count how often each word occurs in there, or find the word that appears the most in there. And finally, the last use case is this categorization case, which is given these categories, the value is going to be given the key acts as a category, and the value is all the things that are in that category. So let's call it word lists. And what you can do is basically, let's go ahead and return word lists. You'll return that at the end. Yes, I know I have not initialized it. Let's go ahead and initialize it to null. So, and in the end, in main, what you can do after reading the file is you can basically say, hey, word lists dot get however many letters, and you have your initial word list. Okay. Everybody following so far, or was I just speaking gibberish here? Because talking and typing is hard. Wasn't sure if I was even speaking English.
I think it was good.
Okay. Let's take a look at another method then, which is the meat of the operation, which is, and here I'm just going to give you your method stubs and explain what's going on. I'm not actually going to code it for you because this is a good problem, but let's go ahead and do hash map. And let's see, the key is string over here, and the value is list of strings. Okay, and let's go ahead and take a look at so if you have not read the PDF about the word families yet, it's kind of important, but how many people want me to go over the concept of word families before I get too far into this?
That'd be nice.
Okay.
Yeah, it makes sense.
All right, so let's go ahead and take so let me show you what it's going to look like, which is, I'm going to show you what the method looks like, and then I'm going to show you what it's going to do. Word families, string, and what we're going to take in over here is, again, I'm going to return null just to be able to quash the error messages. Even in a kind of experimental thing like this or an abstract thing like this, I can't stand it if there's red lines all over my code. Really all you need? Just need the guessed letters. Okay. So let's go ahead and get the tablet up here. Wacom tablet. And all right. Plug it in. Find the pen, which is right on the floor. Okay. So I'm going to pull up the PDF for this because, I totally am organized. And of course, should have had that pulled up to begin with, but hey. Okay, cheating. Cheers, Hangman. Here we go, Hangman. All right, so so hopefully you've read the premise of this so far, which is suppose that basically that the user has had that basically that we are in this state in Hangman, GOA blank, okay? And based off the previous guesses, right? We haven't guessed D or L yet, but maybe we've guessed T, that there's only two possible words left, right? Suppose we've guessed T because we thought it was goat, but we got to know. And there's only two, based on your knowledge of the English language, and there's only two things left, goat and goal. In a fair game of Hangman, you'd have a 50% chance of winning, but in this game, if the computer says, if you guess L, the computer will say, "Oh no, I was thinking of gold." I was thinking of goad the entire time, and if you say goad, it will say, "I was thinking of a goal." So okay, So for this example, let's see how this works from the start. What we're going to have is that we're going to, instead of pretending that, so we're going to work and pretend that English has only the following 4-letter words. This team look good, eggs, echo, edge. Those are the only words in the English language that are 4 letters long from our consideration. Okay, so suppose we're playing Hangman, right? And so basically we are in this state. 1, 2, 3. Let's go ahead and make this much thicker. 1, 2, 3, 4. Okay. Now the idea here is basically we've got hidden 4 letters. So let's see what happens. So we're playing as the computer, and the player guesses a letter, E. Okay. So the idea here is that basically that we want to is that we need to calculate all possible configurations that an answer that the board could take based off of guessing E. Okay. So there are a couple of different configurations based off all the words in the English language that this board could take. Okay. The first possible configuration is we don't reveal anything, right? That's one possible configuration. And this possible configuration is true there we go. This possible configuration would work if, say, basically we were pretending our letters were this, look, or good, right? So if we actually were playing Hangman fairly, the board would look like this. If it was this, or it would look like this if it was look, or it would look like this if it was good. Make sense so far? Now, if however if we simulate the game choosing eggs, it would look like this, or echo, it would also look like this, which would be E, which would be an E over here, but nothing else revealed. If it was team, remember the person's guessing E, so if they guess E, we would have an E over here, but nothing else. And finally, edge. So we also note that basically not only is the number of stuff revealed important, but also the positioning is important. So these are all the based off of our knowledge of the English language. These are all the possible positions that can happen. So we group all the words by these possible board positions. So this looking good, they all go into the blank, 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 blank word family, as we call it. Eggs and echo belong to the E and 3 blank word family. So team belongs to the blank and E and 2 blank word family, and edge belongs to the E blank blank E word family. Make sense? So how do we create these families? We store them in a map. We store these families in a map by doing the following. Basically, we would have a map, and we would have the key be blank, 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 and the value being blank. Let's say the value would be a list, which would be this, look, whatever, and all the rest. And then we would have another key in here for E blank, blank, blank. So how does this get created in the first place? Okay. How do we create these word families in the first place? Well, what we'll do is that we will basically look, I'm going to look at all the words in the word list, which are basically all the words you can still possibly use for this game of Hangman. Okay. So we look at that and we say, hey, okay, let's take a look at, so the player has guessed E. Let's go ahead and see. What is our status for, let me zoom out a bit, actually, so I can have more space to draw. Okay. So the player has guessed E. So what would this look like? Well, it would look like blank, 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 blank. Do I have that in my dictionary yet? No, I do not. So I'm going to create this word family. And I'm going to put this into it. Okay. Now let's go ahead and write, let's look at team. Team would be T-E-A-M, which would be the word family of, let's see, so T has not been guessed yet, so we create a blank. E has been guessed, so we put down an E. A has not been guessed. M has not been guessed, so that's the word family. It does not exist in here yet, in the dictionary yet, so I'm going to go ahead and put team. I'm going to create that word family and put team in there. Then let's look at look. Look, let's see, L hasn't been guessed yet, O hasn't, and K hasn't, so it's blank, blank, blank. Is that word family in there? Yes, it is. So let's go ahead and put that in there now. So, boom. Draw. Okay, this, look, so we append that to the list. And we continue on and on for all the words until we split it up into families. Make sense? So that is the second function. Why did I stop sharing? I should have just swapped windows. So all you need for the second function is these arguments. You take in a list of strings, which is the words, which is all the words you have left. All the words that can be used, that can still be used. And you have a set of characters, all the guessed letters. You don't need to be able to see what the word state currently is. That's actually not needed to generate the word family. You can generate the state based off of guessed letters. And then here's our map, word family. So what you're going to do is create a for loop, go through the word list over here, and basically figure out which family it belongs to. Make sense? Now the next and the final step is, okay, basically we want to look at one of these word families and choose whichever one is the best one to be the new word list. And that's going to be our answer to the user, whether we reveal something or not. So for instance, maybe we go with this one because it has the most options, right? Maybe we go with this one because nothing's been revealed. Maybe we go with edge because it's the most confusing. I don't know. Maybe you choose the one that reveals the least letter. There's a lot of different strategies you can try. I go with the strategy of let's go ahead and do the one with the most options. So we go with the biggest family because that gives us the most future options. Okay. So we would basically say, okay, this is now our current, we would say that because we'd reveal this, say that because this has not changed, their guess is wrong. And now we use this as our hidden list. So as our word list of all the words that are valid for this game. So next we would guess, they would guess O, and we'd split into families, and then basically we would do this. Sorry, we would go with this option of revealing two O's. So the final method then would be that you would call a name would be public static string get best family given, I'm going to go ahead and steal this. hash map families. Yeah, that's really all you need for that method. And you'd basically return the key for the best family. So those are the three methods that that I find really help with organizing this. All right, any questions before I wrap up with this? And if somebody's trying to speak, you're muted. Any questions before I wrap up? Let's see.
That makes sense.
Nothing in chat. Okay. So stop sharing. Stop